Hi, my name is Satish Soropaneni, Director, Product Management from the Automated Advanced Solutions team at Juniper Networks. Welcome to the 400G and Beyond Virtual Summit presentation. I'm going to give a quick overview of all the 400G products in Juniper portfolio. This includes products in QFX, PTX, and MX families. Towards the end, I will also briefly touch on what to expect beyond 400G. But first, let's talk about why 400G and why is it so important now. When it comes to the need for parallel pipes, there are some facts that have always been true. Parallel pipes are just easier to manage. A single port of 400G is easier to manage than 4 individual ports of 100G. Think of the challenges with lags and ECMPs and the inefficiency packet-based hashing brings in. Parallel pipes have lower cost per bit too. A single 400G port on a router, along with the optics, will cost less than 4 individual ports of 400G with their own set of 100G optics. And the same is true for power as well. A single 400G port consumes lower power than the aggregate power consumed by 4 individual ports of 100G. Now let's look at all the places in the network where there is a need to upgrade from 100G to 400G. Here's a view of a large cloud provider network. Let us look closely at all the areas in this network where 400G upgrades could happen. This particular cloud provider has multiple data centers in a given metro region and also operates data centers in multiple regions. Data centers in a given metro region are connected via a DCI network, and the backbone core network provides inter-region connectivity, as well as connectivity to internet service providers. For faster connectivity, cloud provider also operates lots of edge sites, which are typically located in co-location facilities. Since this provider is in the business of providing compute and storage services to enterprise customers, let's start with the demand for 400G in the data center first. As the adoption of public cloud grows, so does the east-west traffic in the data centers. As a result, the result of 400G is foremost realized in the data center leaf and spine layers. This automatically puts pressure on the inner data center links in a given metro region, which means the DCI network capacity also needs to grow. And what better way to increase the capacity than using a 400G? Backbone network links are long-haul links, and hence there's a limit to how many strands of fiber are available for connectivity between regions. 400G enables transport of more bits in a given pair of fibers than continuing with 100G links. Finally, edge sites enable high-speed connectivity of enterprise customers into provider network. As enterprises transport more data in and out of the cloud, it makes a lot of sense to upgrade the edge sites connectivity into the backbone with 400G. Now that we saw 400G is needed everywhere, it is needed in the data center, it is needed in the core networks, and also needed on the edge of the network. We know the routers and switches used in all these networks have vastly different requirements. The features and scale requirements are different, they have different buffer requirements, they also have different power and cost profile. So all these different networks cannot be addressed with a single ASIC. For each of these different use cases, Juniper adopted a different type of ASIC. Broadcom ASICs optimized for high throughput and low scale and buffer are a great choice for data center products. Juniper QFX 5K are based on Broadcom Tomahawk and Triton ones. Juniper uses its own family of ASICs for the core and the edge. PTX is based on Express family of silicons, which offer high fib square with large buffers needed in the core networks. And the latest generation of that ASIC is Triton. MX product line is based on the Trio silicon, which offers super high multidimensional scale, deep buffers, and millions of queues that are needed in the edge networks. And the latest generation of ASIC announced by Juniper is called the Penta ASIC. First, let's go through the product portfolio for data center. Data centers today process immense amount of data. So there is an exponential growth in east-to-west traffic across the different racks in the data center. So the demand for 400G is the most in data center networks. Current data centers serve access speeds are based on 25G. In a typical cloud data center, a 25G NRZ-based 100G port is broken down into 4 individual ports of 25G and connected to the server NIC. This enables high server port density with a single top-of-rack switch. And 100G uplinks from the top-of-rack switches are connected to the next layers in the data center network. Now you can imagine with the availability of 400G, this 25G, 100G generation-based network design can be easily repeated with 100 gig and 400 gig generation. So in this case, it is 100 gig to the server and 400 gig uplinks to the next layers in the data center. This is possible because in both cases, DC network designs are based on a 32-port radix switches. With 50 gig PAM4 SerDes, 12.8 terabits of capacity is now available on 32-port 400 gig switches, which essentially delivers equivalent capacity of a 3-stage class built using 6 32-port 100 gig switches. So a single 12.8 terabit switch based on 400 gig is cheaper to deploy from both CapEx and OpEx point of views. QFX 5K product line based on Broadcom ASICs are widely deployed as top-of-rack switches and also as spine switches in the cloud data centers. Here's a quick view of Juniper 400 gig switch. QFX 5220-32CD, which is based on Broadcom Tomahawk 3, is a 1U 32 by 400 gig system. It is used as a top-of-rack switch with breakout cables for 50 gig or 100 gig server connectivity, and is also used as a building block into multi-stage 400 gig core fabrics. It ships as Junos Evolve, which is essentially current Junos enhanced to run directly on Linux. So customers can use any open source Linux tools in conjunction with the Junos features. For customers who have use for VXLAN tunnels in the data center, Juniper is also working on Triton-4 based 400 gig switches, which will be announced soon, and early information is available to customers under NDA. So that was a quick overview of data center 400 gig products. Now, let us take a look at 400 gig WAN portfolio. First, we will begin with PTX family, then move on to MX. PTX is the Juniper product line for core and peering use cases. It is widely deployed in cloud provider networks, in service provider networks, and also in networks of high-end enterprise customers. The PTX family of routing platforms, which include both fixed and modular systems, are based on Express family of ASICs. Modular platforms include 8-slot and 16-slot and fixed 2U and 3U platforms. In fact, PTX 10003, which is a fixed form factor with 32 ports of 400 gig in a 3-rack unit, was the very first 400 gig platform in the industry. To achieve higher 400 gig densities, Juniper developed a 400 gig optimized 3.6 terabit Triton ASIC that supports a packet rates of 2 billion packets per second. This ASIC offers a very high on-chip capacity and access to 8 gigabytes of external HBM memory per packet buffer. The ASIC supports high filter scale and does not compromise on filter scale even with a wide variety of search key options. It also features a large number of counters and statistics for multidimensional reporting. Triton ASIC is the industry's only ASIC that includes 400 gig MACsec and can enable via a simple software node. Juniper shipped its first Triton-based product early this year and plans to introduce more platforms based on Triton ASIC starting from second half of this year. Line card 1201 is the very first Triton-based line card for PTX product family. It is a 36 by 400 gig line card for the PTX modular systems. This card delivers 14.4 terabits of capacity and is currently shipping on an 8-slot chassis. With this card, the 8-slot chassis provides an aggregate throughput of 115.2 terabits per second. This card is designed to operate up to 40 degrees Celsius at 6,000 feet elevation, giving the flexibility to operate at vastly different regions in the world. Although the ports are 400 gig, can also be broken down into 4 individual ports of 100 gig, and thus a fully loaded 8-slot system can support 1,150 200 gig ports. In addition, Juniper is also investing in Sonic for modular systems, with an intent to offer Sonic not only for data center use cases, but also for MPLS use cases in the core. Juniper will further expand support of this 36 by 400 gig line cards on a 4-slot chassis and a 16-slot chassis, so please stay tuned for new announcements. There is a new network design concept that originated in the data center and now showing lots of promise in the core networks. This is the scale-out design, which when coupled with good automation or manageability offers high availability and flexibility that is often difficult to achieve with scale-up designs. As a result, there's an increased interest in fixed form factors to build large-scale, scale-out LSR fabrics in the core. So a Triton-based 9.6 terabits 1U fixed form factor PTX is also expected later in the year. PTX 10008 with a line card 1201 significantly expands core capacity. With a multi-plane design, the aggregate throughput at each of the core site can easily be doubled or quadrupled based on the number of planes used. This is an alternative to scale-up designs using chassis of greater than 8 slots. With full MPLS capabilities ranging from LDP to RSVP and SRTE, complemented with full traffic statistics visibility, line card 1201 is ideally suited to expand capacity in any core networks in the world. Triton ASICs features 2 million fit capacity and a large count of flexible filters. And when these capabilities are combined with IPFix and S-Flow, PTX line card 1201 can also be used as a peering router. Since line card 1201 ports can also be used as native 100 gig ports, customers can connect other peering routers at 100 gig speeds while connecting into their own core with 400 gig ports. Line card 1201 is also suited for DCI Ethernet and data center spine use cases. Features typically needed in DCI use cases are very close matched to a core feature set, especially in large cloud providers. Line card 1201 is the industry's only device that supports MAC-SEC at 400 gig speeds, which when combined with 400 gig ZR optics becomes an ideal router for secure DCI Ethernet connectivity between different data centers in a given metro region. For customers who prefer deep buffer modular systems, PTX 10008 with line card 1201 can also be used as a spine or a super spine in the data centers. Line card 1201 will also include support for EVPN and VXLAN, which is often used as overlay technology on top of IP fabrics. And to enable lossless traffic, line card 1201 will also support features such as PFC and ECM marking. So that was a quick overview of PTX core routers. Now let's jump into MX, Juniper's flagship router for over a decade, still going strong with new 400 gig capability. MX is known for investment protection. With that in mind, the Penta ASIC, which is the 5th generation ASIC, adds 400 gig capability to the MX family. A single Penta ASIC provides 500 gig of throughput, while also expanding features on previous generation of Trio ASICs. Some of the new capabilities are built-in MAC-SEC and IPsec, and 50% reduction of power per gig when compared with the previous generation. MX960 and MX2K both ship 400 gig line cards based on Penta ASICs. MPC10E, supported on MX960 and MX480 and MX240, has 3 Penta ASICs, providing an aggregate throughput of 1.5 terabits per second. Each card supports at most 3 ports of 400 gig or 15 ports of 100 gig. For the MX2K chassis, MPC11E, which has 8 Penta ASICs, provides an aggregate throughput of 4 terabits per line card. Each card supports at most 8 ports of 400 gig or 40 ports of 100 gig. To go beyond 4 terabits per slot, Juniper is also working on a next generation ASIC which significantly increases the 400 gig density on MX platform. And the details of this new ASIC and platform support can be shared under NDA. So that was a quick overview of all the 400 gig platforms across Juniper. To go beyond 400 gig, we need some technology enablers, similar to how 400 gig was enabled, such as the arrival of 400 gig PAM4, 50 gig SerDes, 100 gig Lambda-based 400 gig optics, and the 16 nanometer ASIC process node that can help reduce the power footprint. The next level of speed is expected to be 800 gig, which will be based on 100 gig SerDes technology. With newer QSFP 112 DD optics, we can support a single 800 gig port or 2 ports of 400 gig sharing the same QSFP cage. This will be enabled with 7 nanometer process node technology. And Juniper is well on its way to define the next generation ASIC and deliver products in 2023. In summary, Juniper will continue to invest in its portfolio with a comprehensive list of modular and fixed platforms for data center, core networks, and edge networks. And all the simple choices we make, either merchant or Juniper custom, are completely driven by the ASIC that best suits for that use case. And most importantly, Juniper will continue to give the one Junos experience that spans from data center to the core and the multi-service edge. For deeper dives into any of the products or technologies, please reach out to Juniper Sales and we'll be more than happy to share details of our product plan and our product plans. Thanks for watching 400G and beyond from Juniper Networks.